we had a look about the different earth pressures, different cases of earth pressure which can act on a retaining wall according to the different conditions of the backfill. Here in this video I will be explaining some of the problems of such cases in the given slides. So this is the first and most simple case, that is that of a dry soil. We will learn how to make the lateral earth pressure diagram and how to calculate the lateral earth force. So as it is a dry soil, this will denote the gamma d, that is the dry unit weight of soil. This is the height of the retaining wall. Therefore at any point, if there is a point at this depth, that is z, here the pressure will be K into gamma into Z, and the maximum pressure will be at the bottom, K into gamma into H. So this will be the line. We will connect the lines and draw this particular triangle. So the earth pressure is K into gamma into H, and the lateral earth pressure force will be the area of this triangle, that is half K gamma H into H. This we have discussed earlier also. Now for the second case, that is saturated soil, here whole of this, the water table is present at the top of the retaining wall, or the backfill is fully saturated with water. So in this case, in case of saturation, we have two components, that is pore water pressure and the soil. So first of all, we will draw the pressure of the soil, which will be maximum at the bottom, that is K into gamma dash into H, where gamma dash is not the saturated but the submerged unit weight, which is given by gamma saturated minus gamma W, where gamma W is the dry unit weight of water. So this will be the first triangle. The total earth pressure at the base will be K gamma dash H plus the pore water pressure, that is gamma W into H. Hence this will be the whole triangle, this triangle we will get. So the total force, the total pressure will be K gamma dash H plus gamma W into H, and total force will be half base into height, that is half into this into the height. This is the second case, which is the saturated soil. Third case is partially saturated, in which some of the portion is dry and some of the portion is saturated. Here for this portion there is no water, so there is no pore water pressure. Hence at this particular depth the value of pressure will be gamma into D into K, which is given here, K into gamma into D. As we continue below, the value will keep on increasing, and at this particular portion the total pressure will be K gamma into W from above plus the lateral earth pressure in this particular portion, which is of, as in the previous case, of two components, that is submerged weight and the pore water pressure. So K into gamma dash into this height, which is H minus T, plus gamma W into H minus T, which is the pore water pressure. Hence we will get this particular diagram. So we will get P1 into P2 and P3, P1, P2 and P3 separately. P1 will be the area of this triangle, P2 will be the area of this rectangle, and P3 will be the area of whole of this triangle, as calculated here. Now we will look at some of problems. The first problem is, this is a retaining wall of height 4 meter, which has two components, that is a soil of unit weight 17 kN per meter cube, and the below soil is saturated and its saturated unit weight is 19 kN per meter cube, and the condition is given at rest condition. For at rest condition, the value of coefficient will be 1 minus sin phi. Kindly note this point. So we will draw the lateral earth pressure diagram. At the topmost portion the pressure will be 0, as stress will be 0. At this portion the pressure or stress will be k into gamma into height of this portion, that is k into 17 into 2. So we get the value 17 at point B. Now at point C, which is at the bottom of retaining wall, we will have the pressure from whole of this back fill, that is this portion as well as this portion. So this will be a combination of both these parts. So sigma C will be sigma B plus this portion. So sigma B is K0 into 2 into 17 as calculated here, that is of dry soil, plus the saturated unit weight plus pore water pressure. So as this is saturated, we will have two components, one of soil and one of water. So we will get 17 plus K into gamma dash, which is gamma saturated minus gamma W into 2 plus 10 into 2, where 10 is the unit weight of water. So we get these three separate values. This is for dry weight, this is for submerged weight, and this is for pore water pressure. So I have written these individually so that it's easier to make the diagram. So at point B the value is 17, at point C the value is 17 plus 9 plus 20. So as you can see, slightly we have drawn the lines up to scale so that we get a proper shape. So now we will divide our area into three portions, one this triangle, second this rectangle, and third is this triangle, bigger triangle. So P1 will be area of this triangle, half into 17 into 2, P2 will be area of this rectangle, which is 17 into 2, width into height, and the third P3 will be area of this whole triangle, which is half into 9 plus 20 into 2. So we get three separate values of P1, P2, P3. We add all these to get the total resultant force P. This resultant force will act at a point Y. So using the laws of mechanics which you have earlier studied, we have to find the location of P, that is Y bar. We already know the location of P1, P2, P3. P1 will act at the centroid of this particular triangle, that is at h by 3. P2 will act at centroid of this rectangle, that is h by 2, and P3 will act at h by 3 of this triangle. So taking moment about C or about any point, we get the value of Y bar. So this is the location of the resultant force P. Our next question is, we have gamma, dry weight and saturated weight at some distance, but note the values of phi are different in both these layers. So what will be the effect of this thing? We will have 2 Ka. In this portion we will have different coefficient, and this portion we will have different coefficients, as phi affects the value of Ka. So we will repeat the question. At this point the stress will be 0. At this point the stress will be K into 17 into 12.5. Ka is calculated 0.271. But note that at point B we will have two values, because here the value of phi is 35, here value is 38. So we will calculate two values, just below and just above. So that's why we get one triangle, this is 11.5, and one shorter line which is 10.1 at point B, because due to different Ka. Similarly at sigma C will have the total pressure of above, that is 10.1 plus 4.8 plus 2.25. 4.8 is due to submerged unit weight of soil, and 25 is due to the pore water pressure. So similarly we have two triangles and one rectangle. We will calculate P1, P2, P3 and the resultant P and its location as done before. So similarly you can practice such questions from your any book of soil mechanics which you have referred earlier, or any other way, so that you can calculate the values of P for different cases. We may have to use these methods to calculate the value of P while designing retaining wall if such cases are given.